Hello, everyone. Today we are going to work on symmetry and point reflections. So, symmetry, a figure has symmetry if there is a rigid motion that maps the figure onto itself. There are three types of symmetry. The first is line symmetry, if a figure has line symmetry or an axis of symmetry. So, in our smiley face here, we could say that it has line symmetry because I could draw a line down the middle, and I could reflect that over that line. Our heart also has line symmetry because we could draw a line horizontally, and that would have line symmetry. Sometimes shapes have more than one line of symmetry. So this shape here actually has several because I could reflect it over that line. I could reflect it over the horizontal. And then I could also reflect it over each diagonal. And last but not least, our triangle. Presuming our triangle is equilateral, it has three lines of symmetry then, the three altitudes. So I want you to pause. I want you to think about this question. What letters in the alphabet have line symmetry? Hello. So if we think about standard fonts, capital letters, these A, M, T, U, V, W, and Y all have vertical line symmetry, and B, C, D, E, and K all have horizontal. Now, yes, some fonts, these letters do not. Some people write capital B with the lower, smaller bubble up top. But if we use standard fonts, these have. So rotational symmetry. If a figure is its own image for some rotation of 180 degrees or less. So yes, everything has rotational symmetry if we rotate it 360. However, we're talking about if it's less than 180, then it has rotational symmetry. The number of times a figure maps onto itself as it rotates from 0 to 360 is called the order of symmetry. Now, for a regular polygon, this equals the number of sides. That's only true for regular polygons. The magnitude of the symmetry is the smallest angle through which a figure can be rotated so that it maps onto itself. So our magnitude is 360 divided by the order. So state whether the figure has rotational symmetry. If yes, copy the figure, locate the symmetry of the center of the symmetry, and state the order and magnitude. So presuming this is a regular hexagon, yes, the order equals 6, and the magnitude is 60, because I did 360 divided by 6. And our center of rotation would be where the radii meet. Letter B is a right triangle. It is not isosceles. It's a scalene right triangle. Therefore, it does not have rotational symmetry. Letter C, that weird shape there, does, but it's only 180 degrees. So its order is 2, and its magnitude is 180. The order is 2 because 180 and 360. Letter D is labeled an equilateral triangle. So yes, order is 3. And then the magnitude equals 120 because it's 360 divided by 3. Letter E, yes. The order is 2 because we can flip it upside down, and the magnitude is 180. Letter F is yes. Its order is 4 because we could move this 1, 2, 3, 4 spots, and its magnitude is 90. The last type is called point symmetry. If a figure is its own image under the rotation of 180. So point symmetry is a specific type of rotational symmetry where it's strictly 180 degrees. So our square, yes. Our equilateral triangle, no. And a circle, yes. Circle has all infinitely many rotational symmetries. Then the last thing we want to talk about is a point reflection. So now we need to remember that point symmetry is when it's rotated 180 degrees. So a point reflection is the same as rotating 180 degrees. But we're not always going to do a point reflection over the origin. So if we have the triangle art, so I want you to pause and plot the triangle. So I plotted my triangle art is reflected through the point 4, 1. So therefore I also plotted 4, 1. What's going to happen is when we're doing a point reflection, which is 180 degrees, we're going to go from our point A to our point, which is down 2, and we're going to continue the same distance, so down 2 more, and that's where A prime is. So for A and R, it's pretty simple because those are horizontal and vertical. So R, I went left for, so I continue to go left for, and I get to my R prime. The one that's a little more complicated is T. So to go from T to that point, I go down to left 4. So I'm going to do that again from that point where I go down to left 4. And that's where T prime is because it's continuing the same pattern. And so my new triangle, after I reflect over the point 4, 1, that red dot, is this blue triangle here, where A prime is the point 4, negative 1, B prime is the point 0, 1, and T prime is the point 0, negative 1. So I want you to pause, and I want you to graph both triangles, and then come back and we'll do the rest together. So what our job is, after we plot those two triangles, is we're trying to find the point of reflection. So I'm going to use A and B as my guide. So A to A prime, our midpoint, because that will always be the point of reflection, is the midpoint. So the midpoint is the point of A to A prime, is the point of reflection. So I can use any of them. So if I use A to A prime, that's fairly simple. It's 1, 2. I could also do C to C prime. So if I did C to C prime, it is 5 plus negative 3 over 2, comma 4 plus 0 over 2, which you see also gives me the point 1, 2. So our point of reflection is the midpoint of the line connecting the two, the pre-image and the image. So that's the end of our video. If you have any questions, please ask me in class.